Hello guys, let's start with another problem which is known as Vowel-Consonant Score. So this is another LeetCode problem, and here we are given a string S consisting of lowercase English letters, spaces and digits. Remember, the string is given, but it not only consists of lowercase English letters, it also consists of space and digits. Remember, digits are also there. So, how can we calculate consonant score? That is described here. That we have to calculate the total number of vowels and the total number of consonants in the string S. And to get the score of the string S, if count of count of consonants is greater than 0, then the score should be the mat.floor value of number of vowels divided by number of consonant, where floor denotes the rounding down to the nearest integer value. Okay. Otherwise, the score should be 0. Got it? It is very simple. First, we have to calculate the count of vowels present in the string and the count of consonants present in the string. Then we have to check whether the number of consonant or the count of consonant is greater than 0. If it is greater than 0, then the score should be number of vowels divided by the number of consonant. Otherwise, the score should be 0. Got it? Very simple. It's looking simple now, but it is not. Why? Because we have to also consider that our string S contains digits as well as space. Here comes the magic, guys. Here comes the magic. What would be our approach? Our approach would be, first of all, calculate the length of the string. So int n is equals to s dot length. Then we'll take 2 to 3 variables. First variable v to store the number of vowels, second variable c to store the number of constant, and third variable score. What would be our score? Okay, let's first consider it 0 as okay initially. Now traverse through the string from 0 till n, the length of the string. Take out each character one by one s dot using the s dot caret ith position. Now check whether it is consonant or vowel. If it is vowel, then increment v, otherwise increment c. Otherwise, no, not otherwise, because there might be digits or spaces. So we have to specifically check for consonants and vowel. How we'll deal with it? See the logic here. For vowels, it is very easy that if ch is equals to a, e, I, o, u, then we have to return or increment our number of vowels. I and O, and last one for U. Otherwise, we have to implement first our vowels. Otherwise, we have to check whether it is consonant or not. How we'll check this? What we can do, first of all, we are checking for vowels. If this is not present, then directly we can check for consonant starting from B to Z. Or we can also check in another way that whether the character is letter or not. The predefined function of strings that we use in Java, that is, it is letter or not. Okay, both can work in this case. So I am using that if ch is greater than equals to character B, and at the same time the char ch is less than equal to character Z. Okay, easy. If it is the case, then increment C. Got it? Now how to check the score? Right guys, how to check the score? That if C is greater than 0, then our score would be V divided by C. Otherwise, we have already initialized our score with 0. We can return score directly. Got it? Let's try to run it. Let's try to run it, guys. Yeah, see, it is running absolutely fine. Here you can see for the first example, the number of vowels are 4, 2 O's, 1 E and 1 A, and the number of consonants are 2, C and R. So consonants are greater than 0, the count is greater than 0. So vowel divided by consonant would be 4 divided by 2, that is equals to 2. The answer is correct. In this case also it is correct. In this case also it is correct. Let's try to submit it. Yeah, it is working fine. So what could be our time and space complexity? See guys, the time complexity we can see very clearly that it is big O of n, that is the size of the string, because one time we are traversing through whole string and checking for each and every character whether it is consonant or vowel or digit or space, something like that. So we are traversing the whole string. Okay, so the time complexity is big O of n. What about the space complexity? Space complexity is here constant, as we are taking 2-3 variables for storing the count of consonant, the count of vowels and the score. Okay, so time complexity is big O of n and space complexity is constant, that is big O of 1. So guys, bye bye. Please watch my videos, like and subscribe it, as well as try to put some comments so that I can improve my channel. And tell me about what kind of videos or what kind of more materials related to computer science you want to learn from me. Okay. Apart from that, pardon me if I don't feel today energetic at all because I was traveling. So that's why. Bye bye.